Hello and welcome back. This time we want to talk about extending digital outputs on our Arduino. As you know, our Arduino here has just a number of pins, input and output pins, and those numbers, they cannot be expanded. So what happens if we want to use simply more outputs, more digital outputs? We are talking now about digital outputs. What happens if you want to have more outputs like this? Okay. Then we could use something like a so-called shift register. Shift register looks like this. Be careful. Be careful. You do have different so-called integrated circuits. That's an integrated circuit. The chip is somewhere inside here, and the main part are the connectors. There's 16 connectors. You have two things which do look pretty much the same. That's the second one here. You see, it looks exactly the same. However, there's written on it a number. And the number we need is called CD 74HC595. Okay, you have it in your script. It's this one, 74HC595. It's printed, it's labeled here. It's very hard to read. It's labeled. Please take care you're using the right one. If you're not using the right one, you end up in an integrated circuit which will get very hot very soon. Because the pin, what in and output is on the pins is different, of course, and the function is also different. So if you touch the integrated circuit, if you touch the chip, if you touch the casing here and it's getting very hot, turn off. Just a hint. Always happens. Always happens. Okay. There's one thing. Now I will do it in parallel a little bit, because if we have a short look, on what we need to build, we need quite a lot of stuff. We need, of course, our IC, our integrated circuit. We need a bunch of cables. We need quite some resistors, and we need quite some LEDs. Because we want to check every output with this LED. So I will start to build this now that you see. Okay, it takes a while. It will take a while, I will promise you. And in parallel, I am going to explain what a shift register is doing. Okay. One hint. Look at this. Autofocus, please do your job. I hope you can see this little notch here. That's on the picture, the left side. You see it? In reality, you will see it for sure. Because this is the notch, and this one is the first pin. Left below the notch is the first pin. Okay. See if I cover most of it. I'm not very satisfied. It's here it's better now, right? Here you see this notch. And now look how I put it in my board. That way. So this means now pin number 1 is here. Okay, pin number 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So the pin numbers are numbered that way. Please look also at your drawing. You do see it. It's very hard to see, but here you can see this notch. Okay. If you have it the other way around, it will also be very, very difficult, or will also get very hot. It again happens all the time. Yeah? So I will now start to build, and in parallel I'm going to explain what this little thing here is doing. Okay. So one thing I will still do. Yeah. I will not do it. Okay. One LED. Next LED. Go in. Third LED. Okay, so this will take a while. While the other Heinz is building up this hardware, in the meantime, I am going to explain you what a shift register is. So we do have a so-called shift register. Okay, it's the 74HC595. Very versatile one. What does it mean? What is shifted? What is a register? Register actually is nothing more than a memory. Okay, and our shift register does have two memories. One memory with 8 bit, so exactly 1 byte. 1, 2, 3, 4, 5, 6, 7, 8. Does not really fit perfect. This memory, this content of this memory, we do see at our output pins. So these are visible here at the outputs of our shift register. Okay, we can see what is inside here. Okay. On some pins of this tiny little integrated circuit. Okay, some pins do show the value of the content. They are somewhere here. We do also have a second, let's call it a shadow register, yeah, which is inside. It also is 1 byte big. 1, 2, 3, 4, 5, 6, 7, 8. Yeah? 8 bits. Yeah? Usually those two do have the same content. Yeah? However, there is one pin at the shift register where I can tell the shift register, hey, listen to me. Ja? Bitte hören Sie auf mich. Oder hör mal zu. Ja? Sagt jetzt was Neues. Tell you something new. Okay? This bit is called the latch. The latch pin. If the latch pin goes low, yeah, then the shift register, we have noticed the shift register will listen to us. Okay, then we can, it also has a so-called data pin. this is where it's listening. It's either low or high. Okay, and then there is also the clock pin. So I'm out of colors. No, here, this one, clock pin. Okay. Every time this clock pin toggles has an edge, yeah, whatever is on the data pin, either it's low or high, will be taken and shifted in here. Okay, whatever is in here will get here. 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 I think you got it. How far are we already with the hardware? Still takes a while. That's it. So every time the clock pin toggles, a data is shifted in, and whatever was previously shifted in, whatever is previously shifted in is running through, and whatever is in the last one, it's shifted out to another pin. I can see it on the special pin on my IC, on my integrated circuit. Okay. So, and then it's gone. Yeah. Then it's forgotten. Yeah. So this will then this data pin will be low or high, whatever I need. Yeah. And with every edge of this clock pin, it will get shifted in. Okay. And I can shift in as many bits as I like. Maximum 8, of course, because then I would shift it out already. It's also one possible case. One possible case is that I do have 2 shift registers, and everything which is shifted out here, I shift in at the next shift register. Okay. Once we are done shifting our data in, we set the latch pin to high again, yeah? And then suddenly this content here is transferred. Yeah? Up to now the output has not changed, but now that I set the latch pin to high, what is internally will appear externally. Yeah? So I can shift it without manipulating the output, shift data in, and then copy it to the output. And these are exactly the 3 pins I need on my Arduino. I have the latch pin, I have the data pin, I have the clock pin. Yeah? These ones I need on my Arduino side, and on the other side I have 8 outputs. And if I cascade more shift registers, I have even more than 8 outputs. Okay. What is still left is that, of course, I need somewhere a power supply. Yeah. I need somewhere my reference, so I need somewhere my ground connected. Yeah. But basically that's it. Yeah. What's about the hardware? Okay. I will now check the following thing. I have now connected the power supply here. Yeah, power supply. And here I have connected the LEDs, and I will now connect the 5 volts. Yeah. And what I'm doing now is I will just check if this up to now is working. Okay, so I plug it in, Tintilin. Is it getting hot? No, that's good. So at least it's getting hot, not hot. And I will try to light up the LEDs one by one and see if I got them correct. It's a little bit of hardware check already. Okay. Wow, it's getting really bright. Really bright. Yes, this is brightness. Good, good, good. Everything's working. Still not getting hot. Here, the voltage regulator is also not getting hot. Passed. It's okay. Yeah. I will now continue to make the connections. Disconnect and continue. Also interesting. Good idea, Hans. In your script you have the pin. This is from the data sheet of this shift register. Okay. So you do have the pins, yeah, and you do see, okay, there's the voltage, there's the ground, yeah, and there is master reset and this output enable. There must be set to a certain value. The master reset must be set to 5 volts so that it's not getting reset, and the output enable must be set to ground, so because it's active ground, then the outputs are enabled. Yeah? This mainly is used for power saving reasons. Okay, so that this everything can work, and I just can turn off the outputs. Yeah? Maybe sometimes useful. We're not using it here. Yeah? What we are using is this latch pin, yeah, STCP, yeah, serial transfer. Yeah. This is the latch pin. Here, if I set this to low, I say, hello, please listen to me. And here, this is the clock pin. Yeah. Here, tell him new data. Look at the data input. The data input is here. Data serial, this means. DS, serial data. One bit after the other is shifted in every time, low or high, when this one changes state. Yeah. So take one, take one, take one, take one, take one, yeah? And shift it in, shift it in, shift it in, shift it in. Yeah. The outputs are here. It's output 0, 1, 2, 3, 4, 5, 6, 7. And this one is the one I've said where it's dropping out. The one which was before at 7 is dropping out here, and so on. Yeah. And once then I set the latch pin back to high, whatever I shifted in, appears at the output. Yeah. So this is how this shift register is working. Okay. Now back to you, Heinz. Looks good, I hope. Huh? So that's the hardware. Plug it in. Bim, bim. Everything's lit. Yeah. Should not bother us up to now. See if this is getting hot now. No. Good. So this was one thing. Now let's come to the coding. Okay. I'll save it again under proper name. Yeah. I've chosen shift register. This is our 13th program. And now let's start. like said, I'm a big fan of these compile time constants. Yeah, so I will define a lot of pin numbers now. So we do have the latch pin for our shift register. This is located at pin number 11. Then we do have the clock pin to shift it in. Yeah. This is on pin number 9. Yeah. Latch pin to tell we are ready. Please listen to us. Please shift register listen to us. Clock pin should also be written clock, hopefully. Clock pin is now new data, now new data, now new data. Okay. And then we of course have the data pin. This is connected to pin number 12. This is how our hardware setup here has been chosen. Okay. And now I do the first time to define my own function. Okay. I want to write a function which should update the shift register with a specific pattern, of bits. Okay. So function definition, just outside setup and loop. It looks exactly like setup and loop. Yeah. I can choose a name now, except setup and loop, of course, because they're already given. And I will call it update shift register. Okay. Somehow I need to tell my function what pattern, what bit pattern I want to give. Yeah, we do have 8 bits there. This is exactly 1 byte. There is in Arduino, there is a type given which is called byte. This is actually like an integer, but only 8 bits wide, an unsigned integer. Okay, so it goes from 0 to 255 with the according bit pattern of the number. Okay, so I call it pattern. If you're interested in how to calculate this pattern out of the byte value, there's a separate video about this. You can watch it if you like. Okay, so first I have to do is set the latch pin to low. Okay, this means please shift register, listen to what I'm telling you. Okay, so we're making a digital write. Yeah, that's right. Yeah, we write to the latch pin. Yeah, and we write there a low. This means listen to us. And of course, somewhat later, we say we are finished. And in between, something has to happen. We need to shift out, or every time we give a new bit of this pattern to the data pin, we have to toggle the clock pin. Then we put the next pin to the data pin, then we toggle the clock pin. Then we put the next bit to the data pin, and then we toggle the clock pin. Every toggle of the clock pin will shift the new data into the shift register. Yeah. There is, luckily, we don't have to code it. There is a command for this, shiftOut. Okay, shiftOut. What does it need? It needs the pin where it needs to send the data. It needs the pin where it always tells we have a new data. Yeah. Then it needs to know in which direction. Should it start with pin number 0, yeah, the least significant bit, or should it start with bit number 8, the most significant bit? So I can choose here LSB first. First one is LSB, least significant bit, or MSB, most significant bit. Yeah, least significant bit first. And of course, what do we want to shift in? Our pattern, our bit pattern, our byte. So this will now shift out this pattern with the least significant bit first. What does it mean on our display here? We will see. Okay, that's our first function which we wrote for ourselves. Okay. In the setup, what do we want to do here? Of course, I want to have some serial output. Serial begin 9600 again. This is what I like. And then we have to set the pin mode. Pin mode, the latch pin. What is this? It's of course an output. And I will now copy because the clock pin and the data pin, they are outputs as well. So copy and paste. Use it often, use it. It saves so much time. Then what should happen? I will update the shift register. I will call here my update shift register. Shift register. Update shift register. I will call my function and now I simply give 0. Okay, so all bits should be cleared. Okay, and now I'll make a serial dot print line, say init ready. Init ready. Okay. What I want to do here is simply I just want to count. I make a static byte, yeah, LEDs, and this should be at the beginning 0, yeah, in my loop. Okay, and then I will simply say LEDs plus plus, so I will add 1 number to the LEDs, yeah, and I will write update shift register LEDs, yeah? And of course I will write something on the serial output, now printing to know the value LEDs. And I do not want to run this too fast, yeah? So I'll say here simply, because it's just a test function right now, delay 100 milliseconds. So every 100 milliseconds it should count one thing further. Okay, what do we expect to see? What do we expect to see? We expect to see that these LEDs are going on one by one, one by one, one by one, one by one. Okay, so I will now upload again. I will now upload this to my Arduino board. It takes a while, of course. Okay, uploading. You see, something is going on there. Okay, you see, this blinks every time here. So this seems to be the least significant bit. Yeah? I wanted to have it the other way around. I wanted to have that this is the least significant bit and this is the most significant bit. Yeah? What can I do about this? What can I do about this? Maybe I show you a little bit bigger. You see, this is blinking very fast. This is now blinking every 100 milliseconds, yeah, counting. And here you can see how it's piling up. Yeah, this is the digital representation. This is our bit number of 1, 2, 3. Now we had got 0. Yeah. Now, if this LED is lit, every LED has a higher value, yeah, double the value of the LED before. like in the binary number system. We see it here. Now I want to have this showing my least significant bit and this the highest, because red I think it should be the highest. Yeah. Okay, so what can we do about this? Yeah, we can also have a look on the serial monitor, and there we see, this is the number, this is the number, and this is the bit representation. Okay, looks interesting. However, if we want to turn this over, yeah, I will simply use here most significant bit first, because then it will be shifted exactly in the opposite direction to the shift register. Yeah. Let's see how this looks. Upload. Exactly the other way around. Okay, so least significant bit shifted it in this direction, most significant bit shifted it from the other direction. The outcome, you see, it's mirrored. Good. Yeah. Now this looks nice. We are satisfied with this. Happy, I don't know. Yeah. But now I want to show you still something else. Yeah. I want to show you that we can even distinguish or read something from the serial input. The serial now just gives us a number. Okay. And I want to show you we can read something out of the serial board. Okay. Therefore, we are going to introduce some new variables. Yeah. What we are reading is a so-called character. We type in a number, yeah, and this is a character. We type in some key, yeah. We type in some character, and this is a character, and this character we want to read. Okay. This one I don't need anymore. Yeah. So, how to read something? First, I have to look if something is available for reading. Yeah. So there is, I can use an if statement. If, yeah. Then I have to check some boolean. Yeah. So, and I want to ask the serial interface if something is available. Yeah. If something is available, then please do something. Okay. And what do we want to do? We're reading a character. Serial dot, and now I use read. The serial read reads a character. If something is available, this what is available will now be in there. Okay. And now I have to check if this character is bigger than 0, the character 0, and this character is less than 7. Yeah. So this means I have typed in a number between 0 and 7. Yeah. I have to do something. And now it's getting a little bit tricky. Now it's getting a little bit tricky indeed, because now I have I read an integer number, and this number, yeah, this number is the character minus 0. Bah, what does this mean? This thing, yeah, this line. The thing is, if I type in a 0 on the keyboard, yeah, it is not the value 0, it's the character 0. And every character has its own code. Okay. There is a representation of character codes. This is called the ASCII-Table. Okay. So if I type in a 0, it's not really a 0, it's the code of 0. Okay. So this is the code of 0. This is why I also use these signs here. These Anführungszeichen, einfache Anführungszeichen. Ja. Das Komma, ab, Komma, Anführungszeichen. Okay. This is why I use them, because I don't want to compare with the value 0. I want to compare with the sign 0, and the sign 0 does have a code in your script, yeah, or you can also look it up in the internet. But in your script, very much below, yeah, you can see every or a lot of signs in this table, and there you can even see that 0 has the code number 48, 1 has the code number 49, 2 has the code number 50, 9 has the code number 57. Yeah? And this is exactly why this is happening here. Yeah? I now take the code of the character. So if it's, for instance, a 0, I take 48 and minus the code of the character. 48 is 0. So the number now represents the value of what I typed in. If I type in 0, it will be 0. If I type in 4, it will be the value 4. Okay? This is what this line is doing. Okay? And now I also show you a new command, bit set. Yeah? And this bit set sets in one byte variable a specific bit. So if I type in 0, it will read here 0, and this will set the bit number 0 in these LEDs. Okay, I will print now. I will print it out also. Yeah. Turning on LED number Okay, looks good. And then if my character equals the character X, so if I typed in X, yeah, then I will delete. Set the LEDs back to 0. I will delete all things, and I will write out cleared. When do we have to update the shift registers? Yeah, when we have to update the shift registers, we are updating the shift registers. We could update it here, yeah. But however, it would be fine if we only update the shift registers if we really need. So every time in LEDs is changing something, I have to update the shift registers. Back here and here. Okay, and that's it. Then we have to check again if something is available, and that's it. Here maybe I change my message. I say, please type in LED number or X. Good. So let's see what is happening. I will upload now. Now this flashing needs to be done. Okay. So here is silence. That's good. I will open the serial monitor. I read, type in LED number or X. And I type in 0, enter. And the LED number 0 is lit. Okay, I type in 5, and the LED number 5 is lit. Okay, great, isn't it? Yeah. Let's have a closer look. Type in 6, next one. Aha, type in 1. If I type in a second time 0, this will of course nothing change. If I type in X, I've cleared it. Okay. This is how we can handle inputs. Yeah, you can see even there is the output exactly like we coded here. Exactly like we coded here. We see it. Yeah. 2, 3, 4. Yeah, and I could even write 0x, 1x, 2x, 3x, 4x, 5x, 6x, 7x. You see? It flashed through because it takes one sign after the other. Okay, yeah. So that's it. How to use the shift register. Yeah? The shift register, you see we have 8 outputs now here, and we can control it with just 3 pins. And the nice thing with this shift registers is you can cascade them. Yeah, you can put a second shift register and shift it through all shift registers, and then you have 16 outputs and still 3 or 32 or whatever. Yeah, just have to take care about the maximum current. Okay, that's clear. But you can expand your outputs. I would say how much you would need. Okay. So that's the nice thing about shift registers. So, and what I want you to perform is that you build. In the other videos we measured the brightness, or we measured the temperature with the thermistor for the temperature, and with the photoresistor for the brightness, and with this little thermistor NTC for the temperature, and this will then be displayed here. Yeah, if we have low temperature or low brightness, only one or nothing should lit. If we have high brightness, all of them should be lit. So it should look a little bit like a scale. Yeah, this is what I want you to do, what I want you to try. If you try it with brightness or temperature, I don't really care. So this is how it should look like. Right now some LEDs are lit, and if I do measure the brightness here because that's easier for me to show. If I make a shadow, you see less LEDs are lit. And if I open again my sensor, the brightness is getting higher and more LEDs. So I can, with the amount of shadow, I can control the number of LEDs which are on. This is the goal. Okay, so for this time, thank you very much for listening. Yeah. See you next time. Goodbye.